Hello, this is Aaron Holmberg from Corvallis Middle School, and this video is to teach students how to multiply 2 times 2-digit numbers when they include decimals. First of all, students, you need to understand that if you have already learned how to do the motions here with multiplying 2 by 2 numbers, and this is no different. Over here, this work is just like you've been doing in class, and so there's only a very small difference. But this video is also going to show you kind of what it means to multiply by a decimal, because as a kid, for example, I remember not quite understanding the size of the numbers that were being made, and that's often a confusion that students have. So first thing I'm going to do is I'm going to show you how you would just work this algorithm, and then the second thing I'm going to do is show you kind of how this algorithm makes sense. So first of all here, we'll just use the standard algorithm, even though it's got decimals in it. 4 times 9 is 36. Carry the 3, 27, 3 is 30, put down a 0 for a placeholder, 1 times 4 is 4, and 1 times 3 is 3, and I add them up, 6, 4, and 6. That's just how it works. That's the standard algorithm as we've been learning in class. Moving over to this one here, 2 times 8 is 16, carry, 2 times 2 is 4, plus the 1 is 5. Put a 0 down as a placeholder. 2 times 8 is 16. Remember to cross out the 1 because you've used it and place the new one up there. 2 times 2 is 4, plus 1 is 5. And add these ones up is 6. That is 11. Carry the 1. And that's 6, so 616. Okay, now the main difference here with multiplying when you have a decimal is that you have to put the decimal into your calculation at the end. And so in the example here, you notice that counting from the right, we have 1 and 2 decimal places in these two factors. And again, I'm always counting this from the right. I'm not going to count it from the left ever. It's always from the right over. So I have 1, 2, and then what I do is I go down to my answer, and starting again from the right, where I could imagine that I would have like a 0.0, if you will, I would move over those two spaces, 1, 2. Okay, now, why does this answer make sense that it's 6.72, 6 and 72 hundredths? Well, just imagine that your answer was 1 times 5. Well, the answer would be 5, right? So it makes sense here that our number would be more than 5, 6.72. You might just cover up the tenths part here and say if you had 1 times 5.6, wouldn't the answer be 5.6? And that makes sense that it should be larger than 5.6 at 6.72. Now the 2/10 part there means that it's 2/10 of 5.6. And later on in this year we'll cover multiplication of fractions so you could understand how that might work. But 2/10 is not a very big piece. It's 2 out of 10 pieces. So if you could take 5.6, break it into 10 pieces, which might be kind of hard to imagine, this would be 2 of those parts added on, and that makes 6.72. So when I come over here, what you're doing is you would solve with a standard algorithm, just like I did on any of these on this page, and then you would count over from the, yes, that's the right, you would count over 1, 2, and then you come down here to your final product, 1, 2, and your decimal goes right there. So this is almost 2, if you notice, like 2 times 3.4. Well, if it was 2 on the bottom and just 3 on the top, 2 times 3 would be 6. So you can see that this answer kind of starts to make sense, that what the decimal's doing in there. It's not 19 times 34, seeming like some huge number. And by the way, 19 times 34, some huge number, would just be 646. We've already done it. But it's 100 times smaller than that. It's 6.46. So yeah, think of that. If I did 6.46 times 100, it would have the same number of zeros that I just kind of crossed out here. That would be 646. Okay, so I go over to my next one here. I've got, again, 2 decimal places, 1, 2, and I come over to my answer, 1, 2 spaces, and I put my decimal in right there. Well, the rest of this page, I have just sort of copied all of the work in there beforehand, and I just want to quickly show what it would look like then. On number 4, you've got 1, 2 decimal spaces, so it's 1, 2. And again, just to check that, 3 times 5 would be 15. So the answer, 17, doesn't look like it's far off. Both factors here are larger than 5 and than 3. So 5 times 3 being 15, 17 seems like it's in the right direction. This one over here, I have 1, 2 decimal places, 1, 2, it's 27.9. And I can sort of ignore that final 0 if I want. And this one here, it has 3. 1, 2, 3. So I come over 1, 2, 3. My answer is 1.092. Now that kind of makes sense because I have 2 times much less than 1 up here. So the answer would be less than 2, and it is. It's 1. Number 7. I have 1, 2, 3. Oops, I did that backwards. I caught myself. It's 1, 2, 3, and it's 1, 2, 3. By the way, you don't have to put in these little loops on the bottom. It's fine if you do on your assignments just to help me understand what you're thinking about. I might be able to see an error if you've miscounted. It could be a good idea that you just practice like this in the beginning. But you could also just count them like this. 1, 2, 3, 1, 2, 3, and put the decimal in right there. That can work, although it's kind of nice if you're first learning this to put those little loops in there. We've got 3 places here again. Oh, I didn't total this one up. Whoops. 5, 6, 4, 3, and 3 decimal places would be right there. I just looked over 3 real quick. Down here we've got 3. They're just in reverse place, 1 on top and 2 on the bottom. So this answer right here, it drops right there. It's kind of a funny looking answer.